All right, let's dive deep into the world of AI that can write code.
Sounds good.
Today we're taking a look at OpenCoder, which is making some serious waves.
Definitely making
It's
waves.
not some, top secret project. This thing is open source, which is a pretty big deal in this space because
Sure.
it means anyone can see how it works, tinker with it,
Yeah,
even build on it.
it's amazing.
It's like, think of it as having the recipe for some gourmet meal, you know?
Right.
But in this case, the meal is a powerful code writing AI.
That's a great analogy. I like that. It's like finally being able to see the ingredients and techniques that go into making something truly exceptional. And the exciting thing about OpenCoder, it's not just some simple recipe. This thing is capable of creating top-tier code on par with
Yeah.
and even exceeding the performance of some of the, those really closely guarded models that are out there.
Yeah, I was blown away by how it stacks up against the competition. But before we get into that,
Right.
let's talk about the foundation, right? The paper dives into how they created this massive, massive data set called Refine Code. And it's huge EE. We're talking 960 billion tokens,
Right.
spanning over 607 programming languages.
That's mind-boggling when you actually think about the sheer scale of it. But it's not just about throwing a ton of data at an AI and just hoping for the best, right?
Mhm.
The OpenCoder team, they recognize that the quality of the data is just as important as the quantity. Think of it like teaching someone to cook. You wouldn't just hand them a random assortment of ingredients.
Right.
You'd want to make sure they're working with high-quality, fresh ingredients,
Yeah.
something that will lead to a delicious outcome.
That makes perfect sense. So how did they go about ensuring that OpenCoder was learning from the creme de la creme of code?
Well, they went through this incredibly rigorous, cleaning process. They started with code from GitHub, but they didn't stop there. They also ventured out into the wild west of the internet, pulling in code-related content from the Common Crawl dataset, which is essentially a snapshot of billions of web pages. It's a monumental task, kind of like sifting for gold in this vast, ever-shifting digital landscape.
So they've got this mountain of code from all over the place. What'd they do to make sure it was top-notch?
Well, they had to filter out all that noise and make sure that OpenCoder was learning from the best examples. They tackled things like eliminating duplicate code, which, get this, it counted for a whopping 75% of the files they collected.
Wow.
Can you imagine? 3 out of every 4 code files were just repeats.
Yeah, I never realized duplication was such a big problem. So getting rid of those duplicates must have been a huge relief for the AI's learning process, right? Less noise, more signal.
Absolutely. But it goes beyond just removing those duplicates. They also had to weed out things that weren't actually code, documents masquerading as code files.
Right.
And then there was the task of removing copyright notices and personal information, essentially scrubbing any data that could identify individuals.
So it sounds like an incredibly meticulous process, but why go to all that trouble? What's the big payoff?
Well, the payoff is in OpenCoder's performance. By training on this meticulously cleaned data set, they were able to ensure that OpenCoder wasn't distracted by irrelevant information or bad coding practices. It's like learning from a master chef versus someone who's just winging it in the kitchen. The results really do speak for themselves.
So they've got this like squeaky clean code,
Hmm.
but they didn't stop there, did they?
No, they
They
didn't.
wanted OpenCoder to be well-rounded, right?
That's right.
The paper mentioned something about going beyond just clean code and incorporating code from the vast expanse of the web.
Yeah, they didn't want OpenCoder to be limited to the specific style and conventions often found on GitHub. So they tapped into that Common Crawl dataset, which is that massive collection of web pages we talked about. The challenge was, how do you find those coding needles in that massive haystack?
Yeah, that sounds daunting. How did they even do that?
Well, they got clever with their approach. They used a small set of existing code as a starting point, kind of like a scent, and then used a tool called fast text to identify similar content within the Common Crawl dataset. It's almost like training a bloodhound to sniff out code. And to make OpenCoder even more versatile, they went the extra mile by annotating Chinese websites that contained code they wanted to ensure it could handle code written in different languages.
It's like they're giving OpenCoder a truly global education in coding, not just one single language or style,
Yeah,
but exposure to all sorts of ways of writing and thinking about code.
exactly. And that's not all. They went a step further with a process called annealing.
Annealing, what's that?
Think of annealing as a specialized training regimen for OpenCoder. They took this already impressive model, and then they gave it a sort of coding boot camp experience. They fed it this curated selection of ultra high quality code that was designed to be logically sound and robust.
So it's like they taught it the basics, and now they're honing its skills with the good stuff. What kind of code are we talking about here?
Well, they use something called the algorithmic corpus, which is essentially a collection of code that's specifically designed to be logically strong, the kind of code you'd need for tackling complex, real-world problems. And here's the really interesting part. They also incorporated synthetic data.
Synthetic data, yeah.
I'm intrigued.
It's kind of like creating a virtual training ground for OpenCoder. They used code snippets paired with their corresponding test cases and even AI-generated coding textbooks.
Hold on. AI-generated coding textbooks.
I know, right?
That's wild. It sounds almost too meta. But it's actually a brilliant strategy. It exposes OpenCoder to different styles of code and different approaches to problem solving. It's like having a diverse set of coding instructors, each with their own unique perspective.
So we've talked about this incredible data they've assembled, but let's peek under the hood for a moment. What's the architecture of OpenCoder like?
Well, imagine OpenCoder coming in two sizes. You've got the 1.5 billion parameter model, which is already pretty impressive, and then there's the behemoth, the 8 billion parameter model. Now, these parameters are like the model's building blocks, the gears that allow it to process information and learn. The more parameters, the more complex its thinking can be.
So the 8 billion parameter model is like the super-powered version.
Exactly. And training that one took some serious computational muscle. Hundreds of specialized processors called GPUs running for hours on end.
Wow, that's intense. It's like building a digital brain from scratch. The paper also mentions something called a two-stage approach to training. Can you explain what that means?
Sure, it's all about making OpenCoder a more well-rounded code-writing machine. In the first stage, they focused on broad knowledge, things like theoretical computer science concepts, algorithms, and the fundamental building blocks of how code works. Then, in the second stage, they shifted gears and focused on practical coding skills using that meticulously curated, high-quality code from GitHub.
So it's not just about knowing how to write code, but understanding the why behind it. It's like the difference between someone who can follow a recipe and someone who truly understands the science of cooking.
That's a fantastic way to put it. And this two-stage approach is a key ingredient in what makes OpenCoder so effective. Welcome back to our deep dive into OpenCoder.
Hi.
We just explored how this powerful model was built, from gathering and cleaning massive amounts of data to a specialized training regimen that would make even the most seasoned coder sweat.
It really is impressive what they accomplished, but I'm eager to see how it actually performs.
Yeah,
Can it actually walk the walk?
Right.
The paper digs into how they benchmarked OpenCoder against other models. I'm dying to hear the results.
Well, let's just say that OpenCoder did not disappoint. They put it through the ringer, with industry standard benchmarks like Human Eval and MBPP.
Okay.
Think of these as like standardized tests for code LLMs. These tests are designed to assess a model's ability to understand instructions, write code, and even debug existing code.
So it's not just about spitting out lines of code. It has to show some problem-solving chops.
Exactly. And OpenCoder proved that it can think logically and solve problems, just like a human programmer would. What's truly remarkable is that it went head-to-head with some of the biggest names in the field, including those proprietary secret recipe AIs we talked about earlier.
I see. So how did it stack up against the competition?
It surpassed many of them.
Wow.
Which is a huge victory for open source and accessibility. It means that anyone can have access to this level of coding power without having to, pay exorbitant fees or jump through hoops.
That's incredible. So not only is it built on this meticulously curated data set, but it also performs exceptionally well. I'm sold. You mentioned earlier that they incorporated code from various sources, including Chinese websites. Did they also test OpenCoder's ability to handle code in multiple programming languages?
Absolutely. They wanted to ensure that OpenCoder wasn't just a one-trick pony, so they used benchmarks like MultiPLE and McEval, which are specifically designed to evaluate a model's performance across multiple programming languages.
Got it. Yeah.
And more than just past. It excelled in these tests, demonstrating its ability to handle languages like C, Fin, Java, Python, and many others.
So it's like the polyglot of the coding AI world. That's amazing. What makes it so adaptable?
Remember that massive data set refined code we discussed earlier?
Yeah.
It contained code in over 607 programming languages. That means OpenCoder was exposed to a wide variety of coding styles and syntax right from the start. It's like growing up in a multilingual household. You naturally pick up different languages and their nuances.
That's a great analogy. So it's not just about memorizing syntax. It's about developing a deep understanding of different coding paradigms and approaches.
Precisely. And remember that rigorous cleaning process we talked about?
Hmm.
It wasn't just about eliminating noise. It was about ensuring that OpenCoder was learning from high-quality examples in each language. Imagine having a team of expert linguists proofreading every line of code, ensuring grammatical accuracy and fluency.
Wow, that's some serious attention to detail. And I imagine that two-stage training approach also plays a role in its adaptability.
Absolutely. By first learning those broad computer science concepts
Hmm.
and then honing in on those specific coding skills, OpenCoder developed a really strong foundation that can be applied across languages. It's like learning the fundamental laws of physics. Once you understand those, you can build anything, whether it's a bridge or a spaceship.
So we've established that OpenCoder performs exceptionally well on these standardized tests. But how does that translate to real-world scenarios? Can it actually help developers write better code?
That's where it gets even more exciting. The paper goes beyond just benchmarks and explores how OpenCoder can be used in practical applications. They talk about using it for code completion, which is that handy feature in many coding tools that suggests code snippets as you type. Imagine having an AI assistant that can anticipate your needs and offer helpful suggestions, saving you time and effort.
That sounds like a game changer. No more spending hours scouring documentation or online forums for the right code snippet. But what about more complex tasks? Can it handle those?
They also discuss using OpenCoder for code generation. Imagine describing what you want your code to do in plain English, and OpenCoder writes the code for you.
That sounds incredibly futuristic, but is that really feasible with current technology?
The technology is advancing rapidly, and open source models like OpenCoder are paving the way. It's like the early days of the internet. We're just beginning to scratch the surface of what's possible.
It's incredibly exciting to see how AI is transforming the world of coding, but I think it's also important to address the elephant in the room. Some people might be worried that AI like this will replace human programmers altogether.
That's an understandable concern, but I don't think it's a realistic scenario. I see AI as a powerful tool that can augment human capabilities, not replace them. It's like having a superpowered assistant who can handle the tedious and repetitive tasks, freeing up human programmers to focus on the more creative and complex aspects of software development.
So it's not about humans versus machines, it's about humans and machines working together.
Exactly. Imagine a world where developers can spend less time debugging and more time designing innovative solutions, where they can focus on the big picture, the user experience, the impact their software will have on the world.
That's a future I can get behind. An open coder, with its open source nature, can be a catalyst for this transformation. It empowers developers, researchers, and anyone who's passionate about coding to explore the potential of AI in a collaborative and transparent way.
That's what's so exciting about it.
Well, we've covered a lot of ground in this deep dive. We've explored the data, the training, the benchmarking. We even dipped our toes into real-world applications. But there's still one crucial aspect left to explore: the code itself.
That's right. In Part 3, we'll take a closer look at the architecture of OpenCoder, the nuts and bolts that make this coding marvel tick. We'll delve into the details of its inner workings, the algorithms that power its intelligence, and the design choices that make it so effective.
Get ready to journey even deeper into the fascinating world of open source code LLMs.
Welcome back to our final part of our deep dive into OpenCoder.
Yes, welcome back.
We've talked about the data it's trained on, how it stacks up against other models, and even its potential to, really shake up the coding world.
It could really change things up.
But now I'm really curious to get under the hood and see what makes this thing tick.
Yeah, let's do it.
The paper goes into some detail about OpenCoder's architecture, and, well, I'm ready to geek out a little bit. Okay, let's dive into those technical nitty-gritty details. Remember how we talked about OpenCoder coming in two sizes, a 1.5 billion parameter model and a larger 8 billion parameter model.
Yeah, those parameters are like the building blocks of the model, right? The more you have, the more complex the AI can get.
Exactly. And the paper lays it all out there, the number of layers, the attention heads, the context window size for each model. It's like a blueprint for anyone who wants to understand how this powerful AI works.
Okay, so I'm no AI engineer, but I'm game to try and learn. What do all those technical details actually tell us about OpenCoder's capabilities?
Well, let's start with the layers. Think of these as like the different stages of processing in the AI's brain. The 8 billion parameter model has a whopping 32 layers, while the smaller one has 24. This means that the larger model can capture much more nuance and complexity in the code it's analyzing.
Gotcha. So more layers equal more sophisticated thinking, like it can handle those more intricate patterns and relationships in the code?
Precisely. And then we have the attention heads. These are like the model's spotlights, allowing it to focus on specific parts of the code that are relevant to whatever task it's trying to do.
Hmm. So instead of just reading the code line by line, it can like jump around and zero in on the most important parts, kind of like how a human programmer might skim through code to find that one relevant section.
That's a great way to think about it. And the more attention heads a model has, the more effectively it can juggle all those multiple pieces of information. The larger OpenCoder model has 32 attention heads, while the smaller one has 14.
So that's a lot of mental juggling. And what about the context window we talked about? What does that do?
Right, so the context window, that's essentially OpenCoder's short-term memory. It determines how much of the code it can keep in mind at any given time.
I see. So a bigger context window means it can handle larger, more complex chunks of code, right?
Exactly. And OpenCoder has a pretty impressive context window size. 892 tokens for the larger model and 4096 for the smaller one.
Mm.
This means it can look at, entire code blocks, even small programs all at once.
Okay, so that's starting to paint a picture for me of how this AI can handle such, sophisticated coding tasks. But I'm still wondering, how did they actually build this thing? What tools did they use?
So they used a framework called Megatron LM for the training process. It's like a specialized toolkit designed for building and training these massive language models. And here's the key. It allows for distributed training, meaning they could harness the power of multiple computers all working together to train this AI.
So it's like a team effort, even at the computer level.
Exactly. And to speed things up even further, they use a technique called DDP gradient overlap, which essentially helps streamline that whole training process.
Wow, it sounds like they pulled out all the stops to make OpenCoder the best it could be.
They absolutely did. And remember, all of these details, they're all available for anyone to see.
Yeah, that's pretty cool.
That's the beauty of open source. It's not some black box. Anyone could look under the hood, study the code. They could even replicate that whole training process if they wanted to.
It's like they're sharing their secret recipe with the whole world. What do you think this means for the future of, coding in general?
I think OpenCoder is a real game changer. It's a testament to the power of open source and collaboration in AI research.
It definitely shows that you don't need to keep everything top secret to achieve some pretty groundbreaking results.
Exactly. By making these powerful tools accessible to everyone, we can really open up a world of possibilities.
That's true.
Imagine a future where, AI coding assistants are commonplace, helping developers of all skill levels write better code, build some amazing things.
It's really inspiring to think about the potential impact. Well, I think we've really covered it all, from the vast data sets to the intricate architecture, those impressive benchmarks, and even the potential to, maybe revolutionize how we all code. OpenCoder is really a shining example of what's possible when, brilliant minds collaborate and share their knowledge.
Yeah, definitely.
It's an invitation to explore, to experiment, to build the future of coding together.
I love it.
That's a fantastic note to end on. Thanks for taking this deep dive with us. And to all our listeners out there, keep coding, keep learning, and who knows, maybe you'll be the one building the next groundbreaking AI.